Welcome to qnawire.
All right, in this problem, we are trying to determine if the reaction is a redox reaction, and if it is, what elements are changing oxidation numbers. So to determine if it's a redox reaction, we really need to figure out the oxidation numbers to begin with. So I'm going to go through and figure out the ones that are kind of easy to look at that follow rules. So in this binary compound, I know bromine is going to be a -1, and there's 3 of them. So to balance out -3, this phosphorus must be +3. Here, oxygen's always -2 unless it's in a peroxide where it's -1, or by itself where it's 0. And hydrogen is always +1 unless it's bonded to a metal, in which case it's -1, or by itself where it's 0. So again, here hydrogen +1, oxygen -2. I'm going to come back to the phosphorus. Again, binary, this is +1 and this is -1. Here I need to write an equation to solve for the oxidation number of phosphorus. So I have 3 hydrogens, each with an oxidation number of +1, plus 1 phosphorus, and I don't know its oxidation number, so I'm going to call it X, plus 3 times the oxidation of oxygen, which is -2, equals the overall charge, which is 0. So 3 plus X minus 6 equals 0. So X minus 3 equals 0. So X equals +3. All right, so I look on both sides. Phosphorus is +3 on the left and on the right. Bromine is -1 on the left and the right. Hydrogen is +1 on the left and the right. And oxygen is -2 on the left and the right. Therefore, nothing is changing oxidation numbers, and this is not a redox reaction. All right, in the next one, we know sodium is going to be +1 and iodine is -1. Here we know hydrogen is going to be, again, be +1 based on the rules we just talked about, and oxygen -2, and I'll come back to chlorine. Sodium is a set charge metal with a positive +1 oxidation number, and oxygen is -2. And again, here hydrogen is bonded to a nonmetal, so it's +1, and so chlorine must be -1. So I'm going to come back over here to my chlorine. You might be able to look at this and reason it out, but just in case, we'll write out the equation. So there's 1 hydrogen with an oxidation number of 1, plus 1 chlorine, so we'll call it X, plus 1 oxygen with an oxidation number of -2, and overall it equals 0. So X minus 1 equals 0. X in this case equals +1. So chlorine is a +1 over here. By the way, the coefficients in your reaction have absolutely nothing to do with oxidation number, so you don't need to worry about them. Here I'm going to solve for the iodine. So I have 1 for sodium, plus an X for iodine, plus 3 times the -2 for oxygen equals 0. So 1 plus X minus 6 equals 0. X minus 5 equals 0. Oxidation number on iodine, must be +5. So a +5 here. So what's changing oxidation numbers? Well, sodium is not, right? It's +1 on both sides. However, iodine is. It's going from -1 to +5. It's losing electrons. It's being oxidized. Hydrogen stays the same. Chlorine and oxygen stays the same, but chlorine is also changing. It's going from +1 to -1. It's gaining electrons. It is being reduced. Therefore, this is a redox reaction. All right, on the third one, again, I'm going to go through and do the easy ones. We know oxygen's -2. Here we know hydrogen's +1 and oxygen's -2. +1, -2, +1, -2, -2, and then I can see, since it's 1 to 1, this must be +2. All right, I'm going to come back over here. I can kind of reason there's 2 -2s, so to cancel out 2 times -2, which is -4, this must be a +4. Here, you might be able to reason it out, but we'll go ahead and write an equation. So that's 1 for the hydrogen, plus X for the nitrogen, plus 3 times -2 equals 0. So 1 plus X minus 6 equals 0. X minus 5 equals 0. X equals +5. So the oxidation number on nitrogen is +5. We come over here to the sulfur. Again, I'm going to write an equation now. I have 2 hydrogens, each with an oxidation number of +1, plus 1 sulfur, so we'll call that 1X, plus 4 times oxygen in this case, equals 0. So that's 2 plus X minus 8 equals 0. x minus 6 equals 0, x equals positive 6. So my oxidation number here is positive 6. So let's see what's changing. Oxygen is negative 2 everywhere. Hydrogen is positive 1 everywhere. Sulfur is positive 4 on the left and positive 6 on the right. Therefore, it is changing. From positive 4 to positive 6, it's losing electrons. It's being oxidized. And nitrogen is going from positive 5 up to positive 2. So it is also changing. It's gaining electrons. It's being reduced. Therefore, this is a redox reaction.